Our next speaker is Dr. Duška Kleut. She is from Vinča, and she will tell us about the experiences they have with the large number of low-cost sensors. And well, the floor is yours. You can share the screen. Thank you.
Thank you everyone for coming to this conference. And today I will be talking about the level of agreement, variability of PM10 and PM2.5 detected with the equivalent low-cost monitors installed in 4 municipalities. So this will be the first presentation, including the UNICEF project that was kind of heating up at the time of our last conference. We have now a lot of data, as Elena said, and we are deciding on how to kind of take consideration to do with such large amount of data. So we will be discussing some comparison methodologies and as well some results we got comparing monthly and daily average data that we wrote some preliminary reports for. And in the end, I will present some conclusions. So the project we got through UNICEF is called Da učimo punim plućima. It was a project, a very large-scale project that had, this is just a small part of it. It involved schools and children and local municipalities, and 170 low-cost devices were developed for this project. But what we were involved was to calibrate and to help develop the network of 135 devices that were set up in 45 schools. So 3 devices in each school in 15 municipalities in central Serbia. And you will hear more about this project from other presentations from Danka and from Miloš. And what I did for this presentation is we tried to compare the results that we got from the schools in 4 of the municipalities or 4 of the cities that have reference measuring stations. So the schools are distributed widely around municipalities or cities. So some are not in the central area of the cities where the reference measuring stations are. And what we have from the Serbian Environmental Protection Agency, or we have the 1-hour measurements of PM10, PM2.5 in those 4 municipalities. And what we have from the local sensor data was that we have calibrated them. They were calibrated in the March of 2022. And what we did was we have made systematic monthly reports to UNICEF and to municipalities. So what we had as the original data that we had was monthly averages for all schools and all municipalities. And we also deployed all the devices in March 2020. And for the first few months, we were just setting it up, and we have official measurements, and the reporting started in May 2020 and ended in May 2023. So we have a lot of data, so a year of data from 135 devices. And so what I will be presenting is the data that we did for the first period of analysis we did, which is from May of 2020 to December of 2022, to December of 2022. So we had the data from the equivalent automatic monitoring station that belongs to SEPA. And what we did for the first stage of reporting was we did daily averages, and we made monthly reports that had also the daily averages from the low-cost devices. And what we did was we averaged also the data from the cities. So every city has every location. So every school has three devices each, and there are also 3 schools in most of the municipalities. So what we did was we created some kind of general database that we reported on monthly, and that was our first step of the evaluation of the performance of the low-cost sensors. And we started first as a measurement of comparison. We explored the coefficient of the correlation and coefficient of determination, and then we came up to this paper by Jiang and his collaborators that also did this on-field test and data calibration of low-cost sensor. So there are multiple papers they did that. They also included this index of agreement as a comparison methodology and methodology of agreement of a large network of local sensors to compare them to the reference measurements or the equivalent measurements. So we also decided to explore this index of agreement and to see what kind of data we can get by trying to compare the results from local sensor, a large local sensor network using this methodology. So it is a bit different. You can see in the formula how it's calculated, and so we try to see what kind of results we will get compared to coefficient determination. So this was the data we got from the reference station. As you can see, this is the whole period we did this preliminary reporting on. So it started in May 2022 and ended at the beginning of January 2023, and there was this gap in the reference data in the middle of September. We think they were doing some sort of refurbishments of the stations. So this is what we had to compare our data to. So these are and so these are some preliminary results we got. So this is all very, very like large scale monthly averages for schools. So every school is an average of the 3 sensors that were placed in the school, and also it was all averaged by month. So you can see the correlation and the determination coefficients, and also the index of agreement of the data we got for all 7 months in the city of Užice, which was interesting for us because we had one of the schools is very close to the reference station. So we had and the other 2 are pretty much on the same distance in a bit of a different area, but pretty much the same distance in meters from the reference station. So it was interesting to us to monitor the data. And Užice also has a very, very interesting kind of setup. It is like in a ravine, and the air tends to get stuck at the very center of town, where the reference station and the first school is. So it was interesting for us. Most of the examples I will show in the presentation are for the city of Užice, because this is I just had to narrow it down a bit. So what we did was we first just tried to estimate the agreement of the measurements we got in schools with it. And you can see that especially in the winter months, in December and November, all the parameters try to get are much better. So the local sensors are in much better agreement than with the reference station than in the summer months. And it also one of the schools, the school number 1 here in Užice, varies a little bit from other schools, and we are still exploring is the distance the only parameter that varies, or what else is involved. So this is the same for PM2.5. And you can see that especially for index of agreement, but also for correlation and the values of the coefficients are much higher for PM2.5. So this is the results just made in a distribution level for all 4 municipalities. So you can see each line in this, each bunch is one school in one municipality, and you can see through the months how the index of agreement, as the new parameter we were trying to estimate, is showing the agreement between the local sensors and the reference stations. And this third municipality is the one that Užice, which is the one that I will show the most examples for. And you can see it has the most predictable variance, because as I said, the first school is very close to the reference station, and the other two are a bit further away, but at pretty much the same distance, and similar conditions apply. So, and as you see in other municipalities, they're much more varied. So what we discovered was studying the index of agreement is that we did this distribution of the values that we got, and as you could see also in the previous slides, the PM2.5 has shown to have the highest number of results between 0.8 and 0.96. Of course, there is some this last part. It doesn't go above 1. It's just that this it is segmented this way. So we kind of conclude from this that this index of agreement is more convenient to describe the distributions of PM2.5, the agreement of PM2.5. So what we did next was we tried to examine just on a very large scale the effects of temperature. So this is just the municipality of Užice again, and how the correlation, how the changes in the average monthly temperature affect the correlation coefficient, and by that also determination, and relative humidity. And you can see that the first school is again behaving a little bit more different than the other two, which is something to be explored. And this is what the data we did estimating the relationship between the distances. So you can see in this picture, this is a map of the town of Užice, and the blue dot is the reference station. And this first school is quite close, but the points are not very accurate. But what you can see is that the first school is like a few hundred meters away from the reference station. The other two are around 1 kilometer away. And you can see that the coefficient of determination and the index of agreement are pretty much following each other, and also the two schools that are pretty much on the same distance have similar behavior regarding this correlation parameters. Just one of the aspects we were considering was because we have to kind of narrow ourselves down, trying to explore such a large amount of data to see what is most useful to conclude. So the next step was this whole thing was done in the preliminary stages, and the reporting we did for UNICEF, where we explored the monthly averages and daily data, but we also, from the local sensors, we had minute resolution data. So what we did was try to go a bit deeper and try to compare our hourly averages from the local sensors and the hourly data we got from SEPA that we had to use as a reference. And we also explored the index of agreement on a daily level and determination coefficient on a daily level. So of course, now when you go deeper into the data, you also have to consider a lot of variances on daily averages, on hourly averages, and the changes in the data. So what we discovered in the preliminary examinations on the daily values, on the hourly values, averaging or calculating of the agreement for 1 day, is that the index of agreement is mostly between 0.5, 0.6, while the coefficient determination is varies much larger. So this first part is connected to the sorry. You can see the much larger variances when you switch to hourly values in the measurements from the local sensors and the reference stations. So what we can conclude is that we use the index of agreement as a measurement device for establishing the agreement between values of PM10 and PM2.5 for the local sensor networks. And we did it, we explored it for the cities, for municipalities that had reference stations, but most examples you saw here was for city of Užice. And what we discovered that on the monthly level, that the index of agreement for all municipalities was between 0.2 and 1, and the both local sensors they show both better correlation and the determination coefficient as well as index of agreement when you consider PM2.5. And we discovered that the index of agreement is proves to have better distribution monitored on a daily or hourly data compared to the monthly level. And so what we also have now to investigate is the influence of temperature, humidity, and distance on the daily value to provide more insight into this large amount of data that we have.
Thank you. Yes, you do have a large amount of data. Are there questions to Duška?
Our health. What to do?
The wishes to help with the data.
So Andrew has a question, please. Proceed to the microphone.
So there are some comments and some questions. First comment is that we all working in this field with these tools, we have to be very clear on the fact to ourselves, I'm the first, that these things are measuring different things.
Yes.
With respect to the
Yes.
even the equivalent one. So it's very difficult to compare their assessment, and more difficult at all when we do it at the distance, as we have seen before. So I wonder what will happen if we actually apply a calibration. So how the agreement will behave if we apply a calibration, and especially a global one. And also, it is very difficult, I think, to really understand the influence of the environment. For example, you have shown a dependence on the temperature, And maybe usually when the temperature is higher, in summertime we have lower concentrations and higher, and when we go at lower concentration and higher temperature, as Milos had pointed out before, the accuracy of this sensor. So maybe the loss of accuracy that you have seen can be done for, I don't know, but can be due to the lower concentration that we are trying to measure, and we are putting them in a very bad condition.
And they were calibrated in March, so the data, of course, the second calibration was done again in March of next year. So the data that are kind of more in the spring or autumn, we assume are have more accuracy because the calibration was done in March. And of course, in winter, when the concentrations are quite high, that you expect to have better accuracy. But I'm assuming the summer is more deviations in the summer months because it was calibrated in March, and the concentration is very low.
The trend of higher accuracy in the winter times is confirmed even in your.
Yes.
Okay, because
because the values are very high, and then the differences are very low here. Especially in these cities that have, like Užice, that have a high level of pollution. Not in all cities.
Not in all cities.
Yes.
And there is another slide in which you have shown that the distance is not so important with the reference. This is happening in all cities, or?
Yeah, so the interesting thing, we have like cities where we have two reference stations very close to each other, and one that is like 5-10 kilometers away in a village. There is much more variance, especially because the climate is different, the air is cleaner, but it's the same municipality, but the measurements are completely different. So it does depend, but on a larger scale, not if it's like a few hundred meters away, so not so much. But because we have we call them municipalities because they're not cities, they're not all in the cities, they're not all in the same area. We have a few cities where the station for that municipality is in a remote village, in a very clean area.
Thank you for processing this very large amount of data and for the nice presentation.